Welcome to the Explainer. Today we're unpacking a pretty fascinating process, the serial dilution of ceftazidime or cefazolin. Now you already know that in pharmacology, precision is literally everything. One tiny miscalculation? Well, that can have massive consequences. So we're going to break down exactly how you take a huge bulk amount of medication and safely walk it all the way down to a microscopic, incredibly specific dose.
I mean, think about it for a second. How on earth do you extract a tiny 2.25 milligram dose from a massive 500 milligram block of dry powder? You obviously can't just scrape off a microscopic corner and hope for the best. You need a rock-solid, systematic approach to safely navigate this kind of extreme mathematical scale. And that, of course, is exactly where serial dilution comes in.
Here's our agenda for today. We'll start off with the microdosing challenge, move right into Step 1, initial reconstitution, tackle Step 2, the precise draw, look at Step 3, final volume adjustment, and wrap it all up with Step 4, the perfect dose.
All right, Part 1, the microdosing challenge. Let's get right into it. Okay, so take a look at this. This flowchart might look a bit intimidating at first glance, right? It's completely full of decimals, volumes, descending arrows, the whole shebang. But we're just going to read it like a map. We're starting at the macro original vial and zooming all the way into the micro final dose. Just remember, every single arrow you see here represents a physical action you actually take, and every box represents the invisible math happening right inside your syringe.
Before we even touch the math, let's just lay out the 4 physical steps. First, we add 2.0 milliliters. Second, we extract exactly 0.09 milliliters. Third, we top that up with fluid to make it 1.0 milliliter. And finally, we extract 0.1 milliliters. If you execute those 4 steps perfectly, you seamlessly transition from 500 milligrams of powder straight down to our 2.25 milligram target.
Which brings us to Step 1, initial reconstitution.
Right off the bat, the flowchart gives us our very first physical action. You take that 500 milligram vial of dry powder, and you add exactly 2.0 milliliters of fluid. And this is a real game changer because once it's reconstituted, we've fundamentally changed how we interact with the drug. We are no longer dealing with weight, we are officially dealing with concentration.
So this right here establishes our baseline. By dissolving that 500 milligrams of drug into 2.0 milliliters of total liquid, we completely lock in our concentration. Think of it this way. Half of that liquid, so 1.0 milliliter, holds exactly half the drug. That means our working concentration moving forward is 250 milligrams for every 1.0 milliliter of fluid.
Moving on to Step 2, the precise draw. Okay, so we've got an initial mixture with 250 milligrams in every milliliter. But remember our actual target? We only need 2.25 milligrams. So how do we cross that massive divide? Well, we do it by executing a highly precise draw of just 0.09 milliliters from our newly reconstituted vial. Just pause and think about how incredibly tiny that is. A single milliliter is already a really small amount of liquid, and we are taking less than 1/10 of it. You absolutely need a specialized syringe and a really steady hand for this part.
And here's the magic of pulling that tiny fraction. It perfectly isolates the exact amount of drug we need. Because if 1 full milliliter holds 250 milligrams, then pulling 0.09 milliliters grabs precisely 22.5 milligrams of the medication. We're essentially leaving the vast majority of the dose behind in the original vial and holding only what we desperately need in the syringe for the next phase.
Now for Step 3, final volume adjustment.
This is where a very specific, absolutely crucial instruction comes into play. The protocol tells us we must make it to 1.0 ml. Notice the phrasing there. It doesn't say add 1.0 ml, it says make it to. So we take that syringe we're holding, the one with just 0.09 milliliters in it, and we add just enough sterile fluid to bring the total volume up to the 1.0 milliliter mark.
By making the volume up to exactly 1.0 milliliter, we haven't actually added any more of the active drug. We still only have that 22.5 milligrams we just isolated. We've just diluted it again, spreading those 22.5 milligrams out over a larger, much easier to measure volume. So now we've got a really workable concentration of 22.5 milligrams sitting in 1.0 milliliter of fluid.
And finally, Step 4, the perfect dose.
We are literally on the home stretch here. The mathematical heavy lifting is done, and we're finally ready to extract that exact microscopic dosage. From that new 1.0 milliliter mixture we just made, the flowchart gives us our final physical instruction. Draw exactly 0.1 milliliters. After that last incredibly tiny draw, this one is a breeze. It's a very standard, easy-to-measure draw on any small medical syringe.
So here's the payoff. By taking exactly 1/10 of our new volume, that 0.1 milliliters, we get exactly 1/10 of the drug suspended inside it. And 1/10 of 22.5 milligrams is, you guessed it, precisely 2.25 milligrams. Through this systematic expansion and reduction, we've hit our precise final dose perfectly.
When you step back and look at the journey we just took, it's actually kind of profound. I mean, we started with a 500 milligram block of solid powder, and through this meticulously calculated series of steps, adding fluid, extracting a microfraction, expanding the volume, and extracting a final fraction, we scaled all the way down to a microscopic liquid dose of 2.25 milligrams. As we wrap up this explainer, I really want you to remember that this protocol isn't just some math puzzle on a page. It is a critical, life-saving system designed to guarantee exact dosing. It protects patients from ineffective underdosing and dangerous overdosing. It requires profound pharmacological precision. So staring down the reality that a single decimal place can completely change an outcome, how can you ensure the processes in your own workflow are just as resilient to human error as the serial dilution? Definitely something to think about.